In this lesson, we're going to continue on with net ionic equations. So we're going to start with another example of a double displacement reaction, and then we're going to look at some single displacement reactions as well as an acid-base reaction. So I'm going to give you guys the molecular equation. Let's say I had sodium carbonate plus calcium nitrate. And this is going to produce 2 moles of sodium nitrate plus calcium carbonate, which is a solid. So let's start with the total ionic equation. So we are going to dissociate aqueous compounds. And we want it to be balanced, so we want to bring this number down with us. I have 2 sodiums, so I'm going to bring that 2 down, but then pull it forward like a coefficient. Remember, this is an ionic equation, and ions have charge. When you are dissociating your aqueous compounds, they need to have charge. Calcium nitrate is also aqueous. It's going to break up into calcium ions. And again, I'm going to take this subscript 2 and pull it forward. I have 2 nitrate ions. On the product side, sodium nitrate is aqueous. It's going to dissociate. This coefficient goes to both sodium and to nitrate. So 2 Na plus 2 NO3 minus. We never break up solids. Next, we'll write the net ionic equation and identify spectator ions. Any ion that is not part of a compound, an ion that we see in both the reactant and product side, can cancel out. So I have 2 Na plus, 2 Na plus, cancel them out. I see 2 aqueous nitrates on the reactant side, 2 aqueous nitrates on the product side. They cancel out. Whatever is left over becomes my net ionic equation. Carbonate plus calcium produces calcium carbonate. Whatever we canceled out will be a spectator ion. We canceled out sodium and we canceled out nitrate. Number 2. We haven't done a single displacement reaction yet. And again, for today, I'm going to give you the molecular. Let's say we had magnesium plus copper 2 chloride producing magnesium chloride plus copper. So this is a single displacement reaction. Magnesium is going to go in and displace copper. So one mistake that students sometimes make is putting a charge on solids. Solids have not ionized, so they don't get a charge. The only time we add charges is if it's an aqueous compound. So magnesium as a solid does not get a charge. Copper 2 chloride. How do I know that it's copper 2? Chloride has a charge of -1, and there's 2 of them. So that means copper has to be 2+ in order to make this a neutral compound. This is an aqueous compound, so it's going to dissociate. And again, we want our reaction to be balanced. So I'm going to take this subscript of 2 and I'm going to pull it forward like a coefficient. On the product side, magnesium chloride is aqueous. It's going to dissociate into magnesium ions. And I have 2 chloride ions. And again, copper on the product side does not get a charge because it is solid. Be careful when you are trying to cancel out ions. Remember, we said only ions that appear on both sides can cancel out. We cannot cancel out magnesium because it is not an ion on the left. Same thing with copper. It is an ion on the reactant side, but a solid on the product side, so it does not cancel. The only ion that I see on both the reactant and the product side is chloride. You can only cancel them out if they are aqueous ions. You cannot cancel out a solid and an ion. Only cancel them out if they're the same. So what's left over? Magnesium as a solid plus copper 2+ ions produces, and then write what's left over on the right side of the arrow. Mg2+ plus copper solid. The only spectator ion was that chloride ion. All right, let's do one more single displacement, and then we'll do an acid-base example. Let's say we had solid chromium reacting with aqueous nickel 2 chloride. This is going to be single displacement. Chromium will come in and displace nickel. If you're ready to try this one on your own, pause the video, come back and check your answer. If you need me to talk through it, stay with me. All right, we are just going to bring down our solid. It does not get a charge. We only add charges when our ionic compound dissociates into ions. Ions have charge. I have 3 nickels, and this is an aqueous compound, so it's going to dissociate. I have 2 chloride ions, but again, that 3 gets multiplied in, so I have 6 Cl minus. On the product side, aqueous solutions dissociate into ions. Ions need charge. And again, this coefficient multiplies in, so 6 chloride ions. Nickel as a solid has not ionized, so it doesn't get a charge. Going from total ionic to net ionic, cancel out any ion on both the reactant and product side. Write whatever is left over. 2 chromium solid plus 3 nickel 2 plus aqueous yields 2 chromium 3 plus aqueous plus 3 nickel solid. Notice that our net ionic equation is balanced. 2 chromiums on each side, 3 nickels on each side. It's also balanced in terms of charge. The only spectator ion would be that chloride ion. Last one that I want to do is an acid-base example, because this one just looks a little different. You would do it the exact same way. An acid-base neutralization reaction is just a double displacement reaction. Let's say I had hydrobromic acid reacting with barium hydroxide to produce barium bromide plus water. And water is a liquid. That's probably where students get tripped up. You have to remember that water is a liquid. Same 3 questions. We'll start with the total ionic equation. We'll break that down to the net ionic equation, and we'll identify the spectator ions. Compounds that are aqueous will dissociate. I have 2 hydrogens, and ionic compounds dissociate into its individual ions, and ions have charge. Again, that coefficient goes to every ion in the ionic compound, so I also have 2 bromides. Barium hydroxide is aqueous. It's going to dissociate into its individual ions. It's going to break up into barium ions and hydroxide ions. And I have 2 hydroxide ions. I'm going to take that subscript and I'm going to pull it forward like a coefficient. On the product side, barium bromide is aqueous. It's going to dissociate into its individual ions. Again, we want our reaction to be balanced. I have 2 bromides. I'm going to pull that forward like a coefficient, so I have 2 bromides. We only break up aqueous compounds. We said never break up a solid. You never break up a liquid. You only break up aqueous compounds. Water is a liquid. It's not aqueous, so it doesn't break up. Let's go through and cancel ions that are the same on both sides of the arrow. 2 Br minus, 2 Br minus. So we can cancel out the bromide ion. Ba2 plus, Ba2 plus. Let's cancel out the barium ions. So what do we have left? 2 hydrogen plus 2 OH minus yields 2 H2O. Spectator ions is whatever we canceled out. I canceled out bromide ions and barium 2+ ions. So those would be my spectator ions.